Hey everyone, welcome back to the channel. If you're new here, don't forget to hit that subscribe button and ring the bell for more AI and NLP content. Today, we're diving deep into something absolutely fundamental to natural language processing, the NLP pipeline. Have you ever wondered how Siri understands your voice, or how Google Translate works? Or how ChatGPT processes your questions? It all starts with a sophisticated pipeline that transforms raw, messy text into something machines can actually understand. By the end of this video, you'll understand every single stage, from raw data to meaningful insights. We'll cover the core stages, look at real code examples, and even explore some advanced techniques. So, grab your coffee and let's get started. Let's start at the very beginning, data acquisition. This is where we gather the raw text data that we'll be working with. Data can come from virtually anywhere: social media posts, customer reviews, news articles, medical records, legal documents, or even transcribed speech. The key here is that this data is completely raw and unstructured. Here's a simple example of how we might acquire data using Python. We could scrape a website, read from files, or pull from APIs. In this example, we're reading customer reviews from a CSV file. The important thing to remember is that at this stage, the data is messy. It has typos, emoji, URLs, HTML tags, you name it. That's why we need the next stage. Stage 2 is text cleaning, and trust me, this is where the magic starts to happen. Raw text is like a diamond in the rough. Before we can work with it, we need to clean it up. We're talking about removing HTML tags, URLs, email addresses, special characters, extra white spaces, and yes, even those emoji. Here's what text cleaning looks like in action. We use regular expressions, or regex, to identify and remove unwanted patterns. Look at this before and after example. See how much cleaner the text becomes? We've removed the URL, the HTML tags, and normalized the white space. Now we're ready for the real pre-processing work. Now we enter the heart of the pipeline, text pre-processing. This stage actually has several substages, and each one is crucial. Let's break them down one by one. First up, sentence segmentation. This is where we split paragraphs into individual sentences. Now, you might think this is as simple as splitting on periods, but it's actually trickier than that. What about Dr. Smith or USA? We don't want to split there. That's why we use sophisticated tools like NLTK's Sentence Tokenizer. It understands these edge cases and segments text intelligently. Next is tokenization, breaking sentences into individual words or tokens. Think of this as breaking down a sentence into its smallest meaningful units. These tokens become the building blocks for everything that follows. Here's how tokenization works in practice. We take a sentence like NLP is amazing and break it into individual tokens. Notice how punctuation can be separated too. That's important for analysis. Lowercasing is simple but powerful. We convert all text to lowercase to ensure consistency. Without this step, Apple, the company, and apple, the fruit, would be treated as completely different words. For most NLP tasks, we want to treat them the same way. One line of code, huge impact on consistency. Now, stop word removal. This is where we filter out the noise. Words like the, is, and, they appear everywhere but don't carry much meaning on their own. Removing them helps us focus on the words that actually matter. Look at this example. After removing stop words, we're left with just the meaningful content words. This reduces dimensionality and improves model performance. One of the most important pre-processing steps, stemming and lemmatization. These techniques reduce words to their base or root form. Running, ran, and runs all get reduced to run. This helps the model understand that these are all related to the same concept. Now, there's a key difference between stemming and lemmatization. Stemming is cruder, it just chops off word endings. Sometimes you get weird results like studi from studies. Lemmatization is smarter. It uses vocabulary and morphological analysis to return the actual root word. Studies become study, a real word. Here's how both work in practice. For most applications, lemmatization gives better results, but stemming is faster. Last but not least, removing digits and punctuation. Depending on your task, numbers and punctuation might not be relevant. For sentiment analysis of movie reviews, we probably don't need the punctuation marks. It's as simple as using regex or translate methods to strip these characters out. All right, we've cleaned and pre-processed our text. Now comes feature engineering, where we convert text into numbers that machine learning models can work with. Remember, computers don't understand words, they understand numbers. This stage is all about that translation. The simplest approach is bag of words. We just count how many times each word appears. It's simple, but loses word order information. TF-IDF is smarter. It weighs words by how important they are across all documents. Rare words get higher scores. But the real game changer, word embeddings, like Word2Vec or modern transformer embeddings, these capture semantic meaning. The model learns that king is to queen as man is to woman. Here's how we might create TF-IDF features in scikit-learn. This matrix becomes the input to our machine learning model. Now, the fun part, model building. This is where we actually train our NLP model. The choice of model depends on your task. For simple text classification, naive Bayes or logistic regression might work great. For more complex tasks, you might use LSTMs, transformers, or even fine-tuned models like BERT. Here's a complete example of training a sentiment classifier. We use our TF-IDF features and train a logistic regression model. Notice how clean and simple this is thanks to sklearn. The model learns patterns in the training data, which features correlate with positive or negative sentiment. Then it can predict on new, unseen text. Building a model is one thing, but how do we know if it's actually good? That's where evaluation comes in. For classification tasks, we look at accuracy, precision, recall, and F1 score. Accuracy tells us overall correctness. Precision asks, of the positives we predicted, how many were actually positive? Recall asks, of all actual positives, how many did we catch? The confusion matrix is incredibly useful. It shows exactly where your model is making mistakes. Are you getting false positives or false negatives? Here is how we evaluate our model and visualize the results. Always look at multiple metrics. Accuracy alone can be misleading, especially with imbalanced datasets. The final core stage, deployment and inference. This is where your model goes from a notebook to the real world. Deployment means making your model accessible, maybe as a web API, a mobile app, or integrated into a larger system. Users send new text and your model returns predictions in real time. Here's a simple example using Flask to create an API endpoint. A user sends text, we pre-process it the same way we did during training and return the prediction. Critical point. You must pre-process new data exactly the same way as your training data. Same cleaning, same tokenization, same vectorizer. Otherwise, your predictions will be garbage. All right, we've covered the core pipeline, but let's level up and look at some advanced techniques that take NLP to the next level. First up, part of speech tagging or POS tagging. This is where we label each word with its grammatical role. Is book a noun or a verb? It depends on context. I read a book, noun. Please book a ticket, verb. POS tagging figures this out. Libraries like Spacy make this incredibly easy. Look how it identifies nouns, verbs, adjectives, and more. This is super useful for tasks like information extraction or text generation. Named Entity Recognition, or NER, identifies and classifies named entities like people, organizations, locations, dates, and more. In the sentence, Elon Musk founded SpaceX in California, NER would identify Elon Musk as a person, SpaceX as an organization, and California as a location. Spacy has pre-trained models that are incredibly accurate at this. Look at this example. It even identifies money amounts and dates. NER is crucial for applications like news analysis, resume parsing, customer support ticket routing, anywhere you need to extract structured information from unstructured text. Dependency parsing takes us even deeper into grammatical structure. It maps out the relationships between words. Every word in a sentence relates to other words. Which word is the subject? What's the object? What modifies what? Dependency parsing creates a tree structure showing all these relationships. Look at this beautiful visualization. We can see exactly how each word relates to others. Cat is the subject of sat, mat is modified by the, and so on. Spacey makes this accessible too. This kind of deep syntactic understanding is used in machine translation, question answering, and text summarization. Last advanced technique, chunking. This groups words into meaningful phrases. Instead of individual words, we identify noun phrases like the big red car or verb phrases like is running quickly. This captures multi-word expressions that should be treated as units. Here's how we can extract noun phrases using NLTK. This is especially useful for keyword extraction and information retrieval. And there you have it. We've journeyed through the entire NLP pipeline, from raw, messy text all the way to advanced linguistic analysis. Let's quickly recap. We acquire data, clean it, pre-process it through tokenization and normalization, feature engineer, build and evaluate models, and deploy them to production. And for advanced applications, we can layer on POS tagging, NER, dependency parsing, and chunking. The beautiful thing about NLP is that you can start simple and gradually add complexity as needed. You don't always need every stage. It depends on your specific task. If you found this helpful, smash that like button, subscribe for more AI and NLP content, and check out the links in the description for the code examples and additional resources. Thanks for watching, and I'll see you in the next video. Keep learning, keep coding, and remember, every AI system starts with a solid pipeline. Peace.